Welcome back everyone to this lecture series on missing data. In part 1, we're going to give you an overview of the options you have when dealing with missing data. And then in part 2, we'll actually show you how to implement these options with Pandas. As you are already aware of, real-world datasets are often going to be missing data for a wide variety of reasons. Unfortunately, many machine learning models and statistical methods cannot work with missing data points. They require some number to be there. So, if that's the case, we need to decide what to do with the missing data. And it's important to note that when you're actually reading in missing values with Pandas, it's going to display them as NaN values, which stands for not a number. It should also be noted that newer versions of Pandas actually have some specialized null Pandas values, such as pd.nat, meaning not a timestamp. And what's nice about this, it just implies the value missing should be of a particular data type, such as a timestamp. So for example, if you read in a bunch of stock ticker data that was the price of a stock with a timestamp associated with it, and for some reason you were missing a timestamp, then the newer versions of Pandas, instead of just replacing it as a standard NaN value, it would replace it as a specialized Pandas NAT value, in order to just display the fact that we know this data is missing, but we also know that it should be some timestamp of some sort. For our use cases, we don't need really to worry about what actual NaN type here. There's a deeper discussion of it inside the lecture Jupyter Notebook, but really we just need to worry about the 3 options and the 3 method calls to use within Pandas. So the options for dealing with missing data are to simply keep the missing data, remove the missing data, or replace the missing data. And it should also be noted that later on in the feature engineering section, we're going to have a deeper discussion of how to choose these options depending on the situation. However, a really common question I get from students is, hey, I have this particular data set, which options should I choose? And you should note, there's never a 100% correct approach that applies to all circumstances. It really depends on the exact situation you encounter and what trade-offs you're willing to make. Each of these options has its pros and its cons. So let's discuss these options in more detail. Let's start with discussing keeping the missing data as is. Basically, if you're missing a data point and it shows up as not a number within Pandas data frame, you just go ahead and leave it be as not a number. So the pros is, this is the easiest to do. You just read in the data and that's it. You're pretty much done. And the other pro is that it does not manipulate or change the true data. Your data set was missing a value, and so whenever you're going to use it, you're going to report that it's missing that value. So what are the cons here? Well, unfortunately, many methods do not support a not a null value. Some machine learning methods do, but many do not. They require some sort of number to be there. And the other con is there's often going to be a reasonable guess for filling in that missing data. A really common situation as well is if a data set or data cell happens to be a true value of 0, sometimes an entry system would just log it as a NaN value. For example, if we're dealing with a grocery store that sells products and maybe they were having a giveaway, so they sold the product at a free price, instead of setting the price at 0, maybe they accidentally set it to just missing a price value, since it was technically no price and they were giving it away for free. So in those kind of situations, it's totally reasonable and actually correct to just set the price to 0. So again, depends on the exact situation of when it makes sense to just keep the missing data versus trying to put in a reasonable guess. So pros of keeping the missing data, very easy to do, doesn't manipulate or change anything. So now let's talk about dropping or removing the missing data. The pro to this one is that it's also relatively easy to do. Pandas makes it really easy to either drop a row that's missing some data or drop an entire column or feature that happens to be missing a lot of data points. And what's also nice about this is with Pandas, you can base this on rules. For example, you can drop a row that's missing 2 data points or 3 data points or 4 data points, etc. So what are the cons here? Well, as soon as you start dropping or removing data from your data set, you have the potential to lose a lot of data or potentially useful information. And what's going to do is that also limits trained models for future data. For example, if your current data set is missing a lot of information on a particular feature or column, let's say it's missing data on the weather for a particular day, so you have a bunch of rows and one of the features is the weather for that particular day. And at your particular time point that you're running these machine learning models, you are missing a lot of data on this particular column. So if you just decide to drop that feature column and then you train your machine learning model, if in the future you actually start collecting that weather data and you don't have it missing all the time, unfortunately your previous model was not trained on weather data. So now you have to decide, do I just throw all that data away and start retraining on my new data sets where I am keeping track of the weather, or do I just never take weather into consideration? So it limits the trained models for future data. And again, we'll discuss that particular point when we talk about feature engineering in a future section of this course. So just keep that in mind. This one's a little more complicated with that trained model capability. So I want to talk about a little more about dropping a row versus dropping a column or feature. So when should we think about dropping a row? Here we can see we have these countries. Each country is a row, and then we have features of that country, such as the year, population, GDP, and area. And in this particular situation, it probably makes sense to drop a row when a lot of information about that particular row is missing. So we can see here for the United States, we only have the year. We're missing population, GDP, area. For this particular case, it wouldn't make sense to drop population, GDP, and area because we have that information for all the other rows except for USA. And in this particular situation, we're going to pretend that we can't just look up population, GDP, and area. So here, it makes sense to drop the row for USA because we're missing a lot of information just for that row. Downside is we are losing what could be a potentially valid data point, but in this case, there's not really any predictive information here because most of it was missing to begin with. So we should probably just remove USA because clearly this data point as a row should be dropped. It doesn't have any useful information in it. It's often a good idea to calculate a percentage of what data is dropped. So for example, here, if we drop United States, we're actually dropping a third of all our data, 33%. That's pretty high because this is such a small data set. But you can imagine if we had 200 countries, it's not a big deal to just drop one of them. Now, let's talk about dropping a feature column. Dropping a feature column is a good choice if every row or most rows are missing that particular value. So now you'll note we have a different situation where we have a lot of information for all the countries, except for some reason, only a few countries have information about that area column. So in this case, it would make sense to drop the column instead of dropping rows United States and Canada. Because USA and Canada, we actually have a lot of information about them. It just so happens to be that we're missing the area. And in conjunction with that, it looks like we're missing the area for multiple countries. So in this kind of simplified case, it would make more sense to drop the area column instead of dropping both USA and Canada rows. Finally, let's talk about the more complex situation where we decide to fill in the missing data. And the pros here is that this has the potential to save a lot of data points for use in training a model. However, what are the cons? This is the hardest to do, and importantly, it's somewhat arbitrary. At the end of the day, if you're filling in missing data with some sort of statistical estimation, you are, in fact, just making up a number. Now, it could be a very reasonable number to make up, given the statistical estimation method you're using, but it does have the potential to lead to false conclusions. So you should always be very careful with the reasoning you're using on filling in that missing data point. So, for example, what if we are filling in missing data where we want to fill with the same value? So here I have a situation for my data set where I have different countries, the year, the population, GDP, and now this other column here is called carriers, and it stands for how many aircraft carriers are present in the country's navy. And in this particular case, what happened is Canada and Mexico don't have any aircraft carriers in their navy for this particular data set. So instead of filling it in with 0, the data set shows as not a number, as in not relevant because there are no aircraft carriers. So it's a really good choice to replace nan if it was just a placeholder for something like 0. So again, with that grocery price example that we talked about earlier, it's a good idea to just say, hey, all these null values, they're actually just place markers or placeholders for 0, since there are no aircraft carriers for that particular country. In this case, this is a great situation to fill in the missing data, and you just say, hey, this was a placeholder for 0. Now, obviously, that takes some domain experience and a little bit of research to make sure that this is a valid choice. Now, there's the other option of filling it in with an interpolated or estimated value. And again, this is kind of one of those harder or more complex decisions to make. So this requires a lot of reasonable assumptions and a lot of domain experience. So this last column represents some percentage of something. And often in data sets, you may try to fill this in, maybe even using interpolation. So you can see here it goes from 25% to 75%, and maybe you're thinking Canada is somewhere in between Mexico and USA. We're actually not defining what percentages here on purpose. So in your data set, it could be a reasonable assumption to say, okay, I think Canada's percentage value of some feature should be between Mexico and USA. So then you could interpolate it between 25 and 75 and say 50% is the correct percentage here. Again, this is a totally made-up feature. Percent doesn't really mean anything here. But if you have enough domain experience to say it's not unreasonable to say Canada's percentage is in between Mexico and USA's, you could fill it in with interpolation. Again, this is much harder, requires reasonable assumptions, and at the end of the day, we are technically just making up data for Canada here. Okay, so what we're going to do in part 2 is explore the code syntax in Pandas for dealing with missing values. And later on in the course, when we talk about feature engineering, especially as part of a larger machine learning project, we're going to have a deeper discussion on trying to decide between keeping, removing, and replacing options for a real data set. So just keep that in mind. We're really going to talk about the mechanics of how to do these options with Pandas. Later on, we'll actually show you a real-world discussion on what option we should choose. So I'll see you in part 2, where we actually head to the Jupyter Notebook.